Okay, hello and welcome to the next video, which is on functions and roots of polynomials. This is a topic that I think the questions can look very confusing at first, but they're actually relatively easy simply because there's very little you can do with this topic. So the first thing I want to say is use graphs to your advantage. If you become very comfortable with all the different kinds of graphs and how to sketch them quickly, then when they ask questions about roots or functions, then you can very quickly get an idea of what's going on if you've got a good graph sketched out. So let's say they've given you a function that's a quadratic and it's something like that, and then they ask you in a data sufficiency question whether it will still have two roots. If we do, for example, f of x plus 2 or f of x plus 5. Well, and we'll cover this later on in this video, but for example, this option, all it does is shift it to the left. So that's not going to reduce the number of roots. Whereas this option is going to shift it upwards. And so that may end up changing the number of roots. And so just using graphs effectively can be very quick and a very reliable way of getting to the answer, and just much easier than going algebraically. The next thing I'd say is that if they tell you something is a root of f of x, then we know that f of a is 0. So for example, if I'm given f of x equals ax squared plus bx plus 5, and I'm told that f of 2 equals, or I'm told either I'm told x equals 2 is a root of f of x, or using the point below, x minus 2 is a factor of f of x, then the quickest and most useful way to make use of this is simply plug in the x equals 2 into f of x, and that gives you a very simple simultaneous equation. For example, here we get that f of 2, which we know is 0 because it's a root or a factor, equals, well, x squared is 4, so 4a plus 2b plus 5. And so that piece of information that looked a bit confusing is now immediately just a simple equation. And so depending on what happens in the rest of the question, that's about as much as you can do with that. Okay, then there's a quick tip here that occasionally comes up, and you could do these in sort of other ways, but if you know this tip, this can make questions incredibly simple and quick. Sort of questions that might take you 2 or 3 minutes, otherwise can take you about 5 or 10 seconds. So in a polynomial of this form, so the first thing I want to say is make sure if you've got a polynomial, you make this coefficient 1. You don't want any coefficient next to the highest power of x. Well, the minus the first coefficient, a, is just equal to the sum of the roots. And the GMAT often asks, what is the sum? And let me just give an example, or a couple of examples. Well, that is going to be incredibly difficult to sort of deal with algebraically or anything like that. But just knowing that the coefficient next to the highest power is minus the sum of the roots. So in other words, the sum of the roots here equals 3. And one other thing to be wary of here, though, is if I give you a polynomial like this, what's the sum of the roots here? Well, there is notice that we're missing an x cubed term. There's no coefficient of x cubed. So in other words, the number that's 1 lower than the highest power, x cubed, has a coefficient of 0. So the sum of the roots in this case would be equal to 0. So just make sure you keep an eye out for sort of missing roots, missing powers. And then the other thing that can be useful is just knowing that the last term is the product of the roots, with sort of some minus signs that get a bit annoying. Basically, if it's a cubic, it's minus the last thing is the product of the roots. If it's a quadratic, it's plus the last thing. So effectively, you want to use minus 1 to the n b, or in other words, plus b for quadratics, minus b for cubics, and plus b for quartics. Okay, and so for example, in this question, we know that this is a quartic, so the product of the roots equals 5. In this one here. Okay. The next thing to talk about is make sure you understand and can very quickly deal with transformations. So one way of dealing with them is if I have an expression f of x equals x squared plus 5x plus, let's say, 6, and that factorizes into x plus 3, x plus 2, which we can very quickly sketch out. Something like that. Well, if they then ask us questions about f of x plus 2, it's worth knowing that what that does, if you add, and make sure you don't get this the wrong way around, it's a bit counterintuitive. If you do f of x plus a number, then what this does is it shifts the whole graph 2 to the left. Whereas if I sort of chose to, if I did f of x plus 2 plus 5, first of all, it shifts 2 to the left, and then it shifts 5 upwards. And so just make sure you know what the different transformations do and how to show them on a graph, because that's going to be the easiest way of sort of getting to the answer. So for example, if I'm able to sketch a graph of, well, let's just say we've sketched some graph. It looks like this. And then they ask us what is minus f of x, something about minus f of x. Well, what that does is it just reflects it in the x-axis. So anything that was positive in terms of y becomes negative and vice versa. So it basically becomes this. And then what does f of minus x do? Well, that just reflects it in the y-axis. So effectively, what you want to do is say, okay, anything that was positive is now on the negative side. So I'll sort of draw it. That's going to be, that guy's going to be over here. This guy's going to be over here. It's going to go up and then down. And so just by learning what the graphical representation is, you can sort of get through a lot easier than trying to do algebra, which you'll see in the questions. Okay, and then the last thing to mention is just for composite functions like this, you just have to work out what the function is really before you can start working on it very easily. Although one caveat to that is if they ask you something about, for example, f of g of f of g of f of g of 1, then what I'd work out is I'd just sort of put 1 in at first and just sort of carry it through and see what we end up with. So you'll see examples of that when we get on to questions.